Hi there, this is just a video on equation practice for gravitational potential energy. So what I thought I'd do is have the equation at the top. So gravitational potential energy is equal to mass times the field strength, gravitational field strength, multiplied by the height. So in shorthand, it's just GPE equals mgh. The units are below if you want them. So GPE is in joules, mass in kilograms, gravity or field strength is either newtons per kilogram or meters per second squared. It doesn't matter which. And height is in meters. And at the bottom there's a bit of information. The gravitational field strength on the Earth, which you need to know for your examination, is 9.8 newtons per kilogram or 9.8 meters per second squared. So if you want to get that information down, because that's the equation that we're going to be using, just pause the video, get that down, and then we'll begin. So really straightforward. Just pause the video, do these 3 practice questions. I'll take you through the answers, and then there's 2 more questions on the next slide. Okay, let's have a look. So an object of mass 0.522 kilograms falls from a height of 15.7 meters on Earth. How much gravitational potential energy did the object lose? Because obviously it's going to lose the gravitational potential energy. It's going to, as it falls, convert into kinetic energy and also a little bit of heat. So GPE is equal to mgh. No rearranging or anything, just put the numbers in. So it's 0.522 times, now remember gravitational field strength, we need to know that, so it's 9.8 multiplied by the height, 15.7. Sorry, I should have highlighted the information in the question. Anyway, put that in your calculator. That gives you 80.3 joules. I'll just write 80 joules. Okay, next one, number 2. So an object falls from a height of 24 meters on the moon this time, where gravitational field strength is 1.6 newtons per kilogram, resulting in the object losing 73.2 joules of gravitational potential energy. What is the mass? So we've got the height, we've got the energy, we've got G, and we need to find the mass. So first of all, write the equation. So I've got GPE equals mgh. Now on this one, depending on how good your maths is, you might need some help rearranging it. So we need mass. So we need to make mass the subject. So next to the mass, we've got a G times G and times H. So they're multiplied. So to get them to the other side of the equation, to make M the subject, we need to do the opposite of multiplying, which is, of course, dividing. So GPE divided by, and instead of times in GH, we're going to divide by GH. And that will give us the mass. And then we just need to put the numbers in. So gravitational potential energy, 73.2, divided by gravitational field strength, 1.6, multiplied by the height, 24 meters. And if you put that in your calculator, you will get 1.9 meters. Third one then, so we've got an object of mass 1.96 kilograms, falls from a cliff on Earth, resulting in the object losing 309 joules of gravitational potential energy. We're going to calculate the height. So GPE equals mgh. We're going to do exactly the same as what we did in the previous question, but this time for height. So we need to get rid of a times m and a times g. So the opposite of doing that is obviously dividing. So we divide on the other side. So it's GPE divided by mg, and that will give us the height. Then we can just put the numbers in. So the gravitational potential energy, 309 joules, divided by the mass, which is 1.96, multiplied by G, and remember, G on Earth, 9.8. So if you calculate that, that gives you 16.1 meters. Okay, let's do 2 more questions. So if you want to pause the video and do these 2, and then I'll take you through the answers. Okay, let's go. So on this one, we've got an object of mass 0.835 kilograms, and it falls from an unknown height on Mercury, where G is 3.6 newtons per kilogram, resulting in the object losing 22.6 joules of GPE. Calculate the height. So GPE equals mgh, and then rearrange to find height. So same as last time, GPE. Opposite of timesing by mg is dividing by mg. And that will give us the height. Then we just need to put some numbers in. So GPE, gravitational energy, 22.6, divided by mass 0.835 times gravitational field strength 3.6. So that height will give us 7.5 meters. And then the last one. So an object of mass 0.737 kilograms falls from a height of 1.6 kilometers on Jupiter and loses 29.5 kilojoules of energy. Calculate the gravitational field strength on the surface. So, same equation. GPE equals mgh. Then we just need to rearrange this time to find G. So, gravitational potential energy. And what we need to do to get G, we need to get rid of a times mass and a times height. So the opposite of timesing by mass and height is dividing by mass and height. And that'll give us the gravitational field strength. Then we just need to put the numbers in. You've got to be careful with these ones because we've got some conversions to do. So 29.5 kilojoules, we have to times that by 1,000 because kilo means 1,000. So 29.5 times 1,000 gives us 29,500 joules. Divided by mass, which is 0.737 kilograms, multiplied by the height, 1.6 kilometers. Kilo again means 1,000, so 1.6 times 1,000 is 1,600. And if we calculate that, that gives us 25 newtons per kilogram or 25 meters per second squared. So, hopefully that's okay. And thanks for watching, and I'll speak to you soon.